Checking the title. Good morning, people. This is Getting the LCA credit in LEEDv4. It's Jennifer. I'm Mark. We were starting with this awesome word cloud, which wasn't quite as awesome as we expected it to be, but it's still very helpful for us. And maybe for us old folk, it's still awesome to me that it comes up immediately like that, which is kind of cool. Mm-hmm. One of the things about this, we did this on purpose, a couple of things to describe a green material. And, I've taken things of scrolling down. It's still going live if people want to text something in there. And we see all kinds of different things. The thing I find interesting about this is I don't see anything that's wrong there. Natural, sustainable, actually recycled, durable, low impact, awesome, recyclable, regional, non-toxic, healthy. These are all traits of a green material. These are all correct things. But how do you compare it? How do you, take one material and say, okay, this one's healthy and this one's durable. Which one is green? Which one is greener? And that's I think what we're going to talk about a little bit today.
Yeah, that's good. We have the advance, right? All right. Well, let's get the show on the road then. And I think Mark set the stage really nicely, and that's sort of our overriding message. And I just want to say a few words about my colleague. I'm honored to co-present with Mark. In fact, I'm not worthy, Mark, since you got your LEED Fellow designation last year, or like, as you like to say, LEED Fella, just what we call him.
I'm a LEED Fella.
And that's because he is a good fellow, and Mark really integrates sustainability thoroughly in his life and in his profession. Mark's been really involved in green buildings for over 20 years.
Yep.
Geez, Mark, you look older. Kidding.
I worked in the oil sector for about 15 years before that,
okay.
And I didn't.
Mark has been really involved in the green building world in Canada, very engaged at several levels of the Canada Green Building Council. Mark's principal and director of sustainability at Morrison Hershfield Consulting Engineers. That's a really wide-ranging engineering service company. And Mark is a good fella because he has built and lives in his own LEED Platinum home.
And I get the opportunity to introduce Jennifer O'Connor. Jennifer was born in 1983, and she, graduated in 1983, my mistake. She graduated out of architecture and has one of her teachers here today. She has worked in Canada and the United States, been around, not a typical architect, I would say. Her first job, I think, was in the HVAC industry. Is that correct? Mm-hmm. Has worked for engineers, for architects, went into daylighting research, followed into work research for FP Innovations, and now has ended up as president of the Athena Institute. She's been president since 2011. And Athena, I'm on the board of Athena as well, has been around for 20 years, has been focusing on life cycle assessment before many people knew what the term was. So they were preaching. They were at the first Greenbuild in Austin, and have been here all along. And I'm kind of proud of my association with this great institute.
And Morrison Hershfield's been a long-time partner with Athena, so that's been terrific. All right, next slide. All right, so here's today's learning objectives. We're going to identify the value of LCA. You'll learn how to apply LCA to design projects. You'll get closer to learning how to achieve the LEEDv4 LCA credits, and you'll learn how to measure the environmental impacts of building material choices.
And I think one of the things, this is where Jennifer gets a little nervous because I'm straying a bit from what we've written down. One of the things that drove us coming together was last year we were at Greenbuild, and we watched a presentation about LEEDv4, and there was 100 or so projects that were just trials at that time, and almost none of them had gone for the LCA credit. And the LCA credit is not hard. It's a very good and important credit, so that's one of the drivers. I wanted to say, the only thing I wanted to add on the objective was to say that we want to leave so that you people have the ability to use it, to actually use LCA to make a difference in their next project. So that's what our goal is.
Good. All right. So the agenda today, we're going to do this more or less in 3 parts. Before we dive deep into the credit, we wanted to spend a little time on LCA in general, and not in LCA 101, but we wanted to emphasize a few of the things about LCA that we think bring value to sustainable design practice. So we'll do that, then we'll get into the credit, and then Mark's going to walk us through an example project that could earn the points.
So this is a project that I worked on. It's in Ottawa. That's where I'm from. It's the Rideau Valley Conservation Authority building done by Chris Simmons. I think that word of awesomeness, for me, works really well with not only the project or materials, but the project itself. It was designed around the sun. But as a team, we worked very hard to make those materials green. You know, this was done, it got its LEED, it was the first LEED Gold in Ottawa, and got it in 85, I think, or sorry, 95. 05. You know, when you see there the wood that's up there, this is awesome, Jennifer. Like, this is FSC certified wood. It's regional. If you look around the corner, we've got rock, stone that we quarried out of regional, you know, pits and things like that. We've got concrete that was, again, regional and natural and not emitting gases and high recycled content steel, all the stuff that LEED projects have. So I kind of challenge it and say, these are green materials. I know that. I know that in my head.
So here's where we're playing devil's advocate, because now I can do the challenge and say, that sounds great, and I'm sure it's a great building, and all those materials and technologies and strategies you use sound green, but how do you really know that you've ended up with a building that has a measurably greener footprint?
Yeah, and that one, it was a bit of joking around a bit, because we actually did LCA in this building. We did the thing with LEED. We got all the LEED points that we needed to, but we also did LCA. And we made active decisions on things. Like, for example, the beams on supporting the second floor are steel, but the beams supporting the upper floor are glulam. And that was made with using LCA as a tool to try to reduce the environmental impact. We got an innovation point for that. We kind of scribbled down what we thought was a LEED point using LCA, and the CAGBC accepted it. So we've been using it on projects. We use it all the time. It's a very simple and easy tool to use.
So Mark, on this project, you used LCA to land on your final strategies.
Absolutely.
Okay, so let's talk about what is LCA. Right?
Sounds good.
Okay.
There's the definition. You see the ring, I'm an engineer. A compilation and evaluation of the inputs, outputs, and potential environmental impacts of a product system through its life cycle. I think everyone can agree that that is an awesome definition. Evaluation, inputs and outputs, the potential impacts through its life cycle. You know, I look at that and I say, I really do believe that's the ISO definition.
All right, Mark's an engineer. That's a super straight up, really dry definition. Anyone want us to put a little more color on that, maybe? Okay.
Come on, there's other engineers here.
All right, Mark. Speed course, LCA 101. Go.
So LCA 101. In order to understand LCA is a quantification. Sorry, it's morning, coffee.
Have some coffee, dude.
Quantification of the impacts. So what impacts? If we're going to compare things, we're comparing apples and oranges in here. We have to know what we're using to compare it. So LEED has 6 impact measures. The first one's global warming potential. So remember, it's quantified, it's a number. Global warming potential is measured in CO2 equivalent. You know, methane has a different impact than a different amount of impact on climate change than CO2 does. So that's why it's an equivalent. It takes into account methane and all the other greenhouse gases and comes up with the different impacts. And it's measured in tons or kilograms or pounds of CO2 equivalent. The second one that LEED references is acidification. I grew up in Northern Ontario, and there are all these beautiful lakes up in Northern Ontario that I could canoe on. And they're these aquamarine, beautiful, crystal clear, see down to the bottom. And unfortunately, the reason you can see down to the bottom is there's nothing there. It's not alive anymore. Acid rain has killed several of these lakes, and that's what acidification is. It's measured in the equivalent hydrogen ion concentrations, and it's basically what's coming out of the smokestacks when you're producing a material, when you're driving to get that material to the site and what happens at end of life. Ozone depletion. Ozone depletion is about CFCs and HCFCs. So we already know that in LEED, that we're measuring, or we're trying to promote not using ozone depleting substances in the building. But what about the materials, right? So you got, we choose one material and it was, a cooling system was used that has HCFCs, and that's resulting in ozone depletion, which is causing skin cancer and affecting plants and all kinds of other adverse effects. So photochemical smog, with ozone depletion, it's measured in equivalent CFC11. Photochemical smog, measured in the mass of equivalent H3. Again, same sort of thing. We know what smog does, causes asthma, durability effects, all kinds of other effects on plants. Again, that's what's coming out of the tailpipes when you're moving things. That's what's causing it, and out of the smokestacks. Eutrophication. I was really glad that my daughter learned this in grade 8. Learned what eutrophication is. I had to wait until I graduated university to learn eutrophication, or maybe I just wasn't paying attention in grade 8. But eutrophication is a water pollution measure. It's the amount of nutrients that goes into the water. So, a common source is sulfur and things like that. But in a material, the things that come out of the smokestacks, the effluent that's used when you're cleaning or washing or drying things, that goes into the waterways. It goes down and creates these beautiful algae blooms that have all kinds of adverse effects, choke out the life, make cottage living kind of miserable. And that's measured in the mass of equivalent nitrogen. And then there's fossil fuel consumption, which I think in the past was embodied energy. So now it's evolved into thinking it's not the energy, because all energy is not created equally. So this fossil fuel is a finite resource, and when we use it up, we're using it up. So not to be confused with global warming. That impact's different, but it's a measure of the energy intensity of the product, and only the energy that's derived from fossil fuel sources. So if it's coming from small-scale hydro or wind or something, that's not counted. And that's measured in megajoules. And so those are the 6 that LEED measures. We'll get into how and what happens later. There are other measures. There's, I think, 11 total in Tracy, and it's evolving over time. So there's human health impacts, there's resource use impacts. These are the ones that LEED uses, but that's all. The other ones are good too. So,
but we're talking about the LCA credit and LEED, so that's why we're just going to focus on the ones that are in the credit. Let's go to the next slide. So I'm worried about time. So Mark defined what are the results of LCA. I wanted to do a high-level conceptual conversation about how we get there. What is the process of doing that? And at the risk of oversimplifying, LCA really is 2 big steps. There's the inventory step, and then there's the impact assessment step. So the inventory step is basically an accounting exercise. So everything that goes in and out of the system over its entire life cycle. So the resources consumed and the waste or emissions that come out, and then we inventory those over the entire life cycle. So obviously, constructing products and making buildings involves a tremendous consumption of resource, materials, and energy, and a lot of emission of waste and pollutants, and that has consequences, and that's the impact assessment phase. So when we say all of those flows, what do they add up to in terms of the impacts on air, land, and water, and we report that in the sort of measures that Mark just defined for us. So now let's put all that in the context of a building and how we roll it up. Mark, do you want to speak to that one?
Sure. So there's far too much text on that. I'm not going to get into it in great detail, but the thing we're trying to capture with this slide is LCA is complicated. We take all of the different elements of a building structure, envelope interiors, mechanical, electrical. You'll see the dotted lines. True, like LCA has all of those. the solid lines are what LEED measures. That's what's defined in the credit. And then we take all of that, all of those ingredients and create a bill of materials. So we break every single system, you know, a steel stud wall, into steel studs and bolts and things like that, and fasteners, and create this long bill of materials, and then we apply that through this massive, massive inventory. And we keep track of where it comes and end up through the entire life cycle. So we're taking into account the extraction, when there's something digging iron ore out and has impacts with the fuel used. That's taken into account, moving it and smelting that steel and things. And I'm not picking on steel. Every material has an impact. And then we track those flows of the materials through and into the atmosphere in all of those things and across all of those stages. So it's just an incredibly complicated process.
It's complicated, and the takeaway here is there's a lot of data that's all being rolled together on the products and on the processes associated with making the building. And it would be nice if some organization had a nice, simple, free tool for you that could do that for you. Okay, I'll get to that later. All right. I'd like to spend a couple slides talking about why LCA is so valuable to the sustainability dialogue, and I have a couple of key points I really like to make. I'm sure half of you, at least in the audience, already know this and hopefully agree with me, but if you don't, I'm hoping to open some eyes. And the first aspect that I really want to emphasize is that LCA is getting at embodied effects, because we're usually ignoring those. And we ignore those because we rightfully so put a lot of attention on operating effects of buildings. Wouldn't you say that's true, Mark?
Oh, well, it's all about operating. You know, we know that. I'm an engineer, and I know that operating impacts, that's what we do. Energy efficiency is what Green's about.
Yeah, it's good. So, thank you, Mark, for playing that role. I know he agrees with me. He's just kidding. But
it's partly true.
We often look at a building's environmental impact at the end of life. So when you're thinking, well, cumulatively, operating impacts completely dwarf embodied impacts, so it's pretty easy to let the embodied impacts slide off the plate. But I'd like to suggest that we maybe slide up that time scale a little sooner and don't let that great big operating chunk distract us from the significant footprint that building has before we ever turned on those lights for the first time. So those are the embodied impacts. And the reason we might want to care a little bit more about them, even though they are smaller, is that we have some urgency to some of our environmental concerns like climate change, and we maybe don't have the 60 years of energy savings to wait for. So we ought to maybe work on the year zero stuff and look at bringing that number down a little bit. Just to also give you a few numbers, because I did do a little back of the envelope calculation. Yes, Mark, I can do math a little bit. This is from actually quite a rigorous LCA study that one of my colleagues did to come up with these numbers, so I'm pretty confident in them. So that, and we're just looking at global warming potential here, so basically the carbon footprint. And for this typical 5-story building, to offset that carbon footprint, you'd have to take 367 cars off the road for a year. You could switch out 46,000 incandescent lamps to compact fluorescence, or you could pay $35,000 for a carbon offset. So I think it's actually a significant number. There are other nuances to this, and so Mark, brace yourselves. Here comes an engineering slide. Mark's going to talk through another aspect of this.
It's not an engineering slide. It has no vertical axis. It's just cumulative impact and doesn't say anything about it. See, I can do architecture. The thing we wanted to show here is that if you look at the dotted lines, the green and red, where red being operating and green being embodied effects, the embodied rise very slowly over time. The operating rises quickly but starts at zero. That's a traditional building. As a building gets greener, that steeper line goes down. The operating energy drops over time. A net zero in operating would be zero. It would be just horizontal, but we'd still have those materials up there having an impact. So as buildings get greener, they use more materials. We do things like triple glazing. we use things like thermal mass and more insulation and stuff like that, the embodied impacts go up and the operating go down. So you have this double whammy that the break-even point might stray. If you take a non-green building, it might be in 2 or 3 years. In a green building, it could be 20 or more. You know, at net zero, it doesn't break even. But one other thing that we forgot was that, you know, on the vertical axis, that's cumulated impact. I use the same thing, sort of thinking about climate change. If we had something like eutrophication, it would be completely different. You know, eutrophication is not affected very much by energy use. So if we ignore materials, we're ignoring sort of that aspect of water pollution. So some of the measures are impacted almost exclusively by materials.
Good point.
You know, green is holistic, right?
Yeah, that's a good point. Does anybody still think embodied impacts are too small to care about? I'm just curious. If you're willing to confess that? I thought it would be sort of fun to just scale that up, the total embodied impacts over the course of an entire year of new construction. So I pulled some numbers and did a very quick back of the envelope calculation. And I think if you think about it at that level, I think it really adds up. All right, I want to go to my other favorite thing about LCA, and I think it's super cool, is that LCA is a great tool for transparent disclosure. You've all seen EPDs from manufacturers, so those are manufacturers that are disclosing the LCA data on their products. I think we should be doing that for buildings. And it's something we're super interested in at Athena, is doing environmental building declarations. We've done a couple, and this is the most recent project of folks that worked with us. So this is an R&D building of Lafarge. So it's a concrete R&D building, and they did their building declaration, and then they took a summary of that and they put it on a poster in the lobby of the building, and I love that idea. All right.
So now we're getting into the next part, LEED version 4 in LCA. So LEED 2009 was, and previous versions of LEED were prescriptive based, right? You get credits for using recycled content, regional, which are all good as we started in this conversation. LEED version 4 is the first one to get much more performance-based. So it's measuring, you know, when you look at this, the larger scope, the sourcing, the disclosure, and LCA impacts. There are 2 LCAs mentioned sort of loudly in 2 credits, MRC1 and MRC2, although, you know, LEED version 4 doesn't quite have numbers. I don't know. I'm not comfortable without the numbers. Engineer, sorry. So we did find a checklist that they have that has the numbers. So if you go through the reference guide, it's just called Building Life Cycle Impact Reduction, LCA and Design. Then there's the Building Product Disclosure, EPDs, which also has LCA in it as a method of doing it. We're talking about option 1, MRC1. So MRC1 has 4 options to get credits. So the first 2, 6 points for reusing an historic or a blighted building. Second one for 3 points is just renovating a building, similar to that credit that we used to have before about renovating an old building and the percentage you use, or in that building material reusing elements that are used, buying that reclaimed steel beam or glulam column or whatever it is. Those are all worth 3 points. And then the last one is whole building life cycle assessment, worth up to 5 points. So one thing I wanted to mention about this is that the first 3 are not, they're only available when you're reusing a building or building materials. So they won't be commonly used. The 4th one is much more available. So it can be used in an understanding project, but you can't double count.
So if you're all here, it means you found that option 4 in this credit that looks like a historic renovation credit, and LCA is buried in it. So good for you on that. Mark, just one thing I'm catching. The credit's worth 3 points at least. So just maybe a little bit boo-boo on the slide.
Right, sorry.
The 4th is the innovation credit if you get exemplary performance. The 5th, I just want to explain to folks here, anyone here from Canada, that this credit's been identified as a regional priority credit in about half the Canadian cities. So you could total up to 5. So
that's where that comes from.
Yeah.
Okay.
Onward. Okay, so before Mark gets into the weeds of the credit, I wanted to give you, again, because I like to do the high level before we drill down. So how the credit works is the intention of the credit is that you're going to use LCA during design, and that you're in early design and you do LCA, and you've established sort of your benchmark, what in the credit's going to be called your reference building. And then you take the results of that. As you go through design development, you make some changes with the intention to bring down your numbers. And so you're going to end up with something like what's being expressed in the graph. You've got your early design, and you're aiming for a particular % reduction in at least 3 of the measures, one of which has to be global warming. And then what you end up with, just to put it numerically, that the submittal package would have to include some kind of chart like this, where you're looking for the % change. You need the, is it 10% mark? Sorry, you're going to get there. I'm going to let you do that part. So looking for a certain change and not exceeding by too much in any of those categories.
So there is, not yet. There is only one threshold. It's the baseline building. And in order to get the credit, you need a 10% reduction in global warming and 2 of the other 5 that are up there. Remember, those are all quantified. So we need the 10% reduction in the number to do that. If you get, the way the reference guide is structured, if you get, I forgot one other thing, very important, is you have to have a maximum of 5% increase in the other measures. If you get no increase in any of the measures, you get an innovation point.
Well, you have to have reduction in all 6.
Yeah, and you have to have a reduction in all 6. One thing I wanted to point out a little that I think is very important is the reference guide. This is the first time LEED has attempted a credit like this. The reference guide's a little bit unclear on some of the things. You know, for example, the innovation point, if you read it like
tell me something new about the reference guides. Right?
I'll use an example. The innovation point doesn't say you need the 10% reduction. It actually says if you get no reduction in all of the impact measures, you get an innovation point. And I think if you were reading it, as an engineer would, you would say, okay, awesome, then I can get that very easy without the 10% reduction. That's obviously not the intent. Okay, now we can move on. So I wanted to talk a little bit about the reference building. The reference building, similar to EAC1, to energy efficiency, the reference building is kind of like that. It's identical in footprint. It's identical in function. It has the way the reference guide is structured, gross floor area, orientation, and function. So it has to have, I think it looks almost identical, like that reference building in energy efficiency would. It needs to meet the LEEDv4 energy efficiency prerequisite, the reference building and the design building. That's created a lot of confusion. A lot of people think, and it's in the reference guide, it's not really clear what they mean by that. What the intent there is that you don't get a deficit by having a very inefficient building without insulation as the reference building, that kind of thing. So the reference building is a pretty good building. It does not mean that you have to actually measure the energy impacts. You don't have to do energy modeling. You don't have to do any of that, and you don't have to count for the impacts, which would change the results dramatically. This one is about materials. So acceptable changes. The real intent between this reference building was it's supposed to be when you start the project, you kind of take a building and say, there's my starting point. I'm declaring that to be the reference building. So I say acceptable changes, but it's, the reference building is supposed to be very similar. Lower floor-to-floor height, I believe that is an acceptable change. It doesn't meet any of those criteria that will kick you out or cause problems. Different cladding or insulation, without a doubt. That's an envelope product, so changing a material product, changing beams, columns, floors, cladding, insulation, roofing, all of those things. Different stud spacing. We're not changing a fundamental building type. In my house, I have 19.2-inch spacing studs, which is a real pain when you're trying to hang things up and stuff like that. But nonetheless, I save materials. So using less material is a very good thing for LCA. Alternative spans, elimination of a product is always a good way to reduce environmental impacts. If you were, you can't eliminate, you have to be careful what you eliminate. I think if you eliminate a product within a system, it would be fine. If we took an exterior gypsum board product that was, hidden in assembly and said, you know what, we're going to just use a stronger air barrier or water barrier membrane spanning over the studs. Just get rid of that entirely. I think that would be fine. Some unacceptable changes and why. So a more efficient interior plan, resulting in a smaller building. Awesome green thing, but is not allowed under this credit because we've changed the footprint. So it does result in lower impacts, but we can't count it. Increased thermal mass. Now that one's a weird one. I put it up there because I'm not really that clear. I think if we put thermal mass in the design building, I'm sure we have to count that. We have to account for that. If we put it in the reference building, if we just said, you know what, we're going to make our concrete slabs 10 inches thick. I'm pretty sure an assessor would look at that and say, that's not a typical building. Elimination of a ceiling tile, one of the things we did in RVCA building and accounted for and got a LEED credit for, not in this credit. It's not an envelope component or a structure. A good thing nonetheless. Use of uncommon buildings or systems in the base building or a change of the building footprint.
Okay, Mark, just before you leave that, I just think maybe it's worth emphasizing for folks that almost none of this is actually called out in the reference guide. A few of those things are, like having a different footprint. So because the reference guide is a little bit weak on interpretation, that Mark is sharing his opinion as a really experienced LCA user and as a structural engineer in how he would interpret that. I'm hoping that some of you who leave the room here will end up going for this credit, and then we'll give feedback back, because I think this is a credit that is going to be evolving as US GMBC gets a little bit more feedback.
And I'll do one other thing, though, too, to counter that a bit. Is not only my opinion. We did pass it by other people in LCA, so it's still only a few people's opinion. I have no doubt it will change.
Mark's going to take us through an example of how you might get that credit, and he's going to use this tool, which is the Athena Impact Estimator for buildings. So I just wanted to just speak for a moment about the tool. The Athena Institute has been around for a long time as a nonprofit research collaborative and LCA think tank, and we have a mandate of making LCA as accessible as possible. And so having been working for a long time in LCA and then wanting to bring that to the construction sector, we first, back in 2002, put out the original version of this tool and have been developing it ever since in collaboration with Morrison Hershfield. And the tool is free. So the idea is to have this a simplified tool that has all the data and the complicated LCA methodology in the background, so that you folks that already have super full plates with your real jobs can do this. In my opinion, this is the only reasonable way for you to get the LCA credit. You can use LCA professional tools, which I don't imagine too many people will do, or you use the simple one. So that's the tool. And then I think, Mark, are we going to go into the example?
Yeah.
Okay.
Well, the inputs first. But so the tool, as Jennifer said, it's free. No one's making any money off of this. It's a not-for-profit and everything. So I feel ethical in talking about it a bit. I'm sure other tools are going to evolve that will help this. LEED doesn't say you have to use Athena or anything like that. Athena is a compliant tool, and other tools, I know some are evolving, and I'm sure others will respond to it. So it's kind of whatever you use. But just to kind of demonstrate how LCA works and how this tool is designed, and to demonstrate that it's not hard. You don't have to be an LCA expert in it. The one on the left here is the opening slide when you take a new project. So you do things like project location. That location, when you click it, it defines a whole bunch of stuff. It defines the energy grid you're on. It defines the material distances and all the impacts from those material distances. It defines a whole bunch of other things. Building type, there's a whole bunch of them. That defines the way things are maintained. A commercial building is maintained differently than a residential building, and the lifespan of materials of a roof, for example, might be different. That's another thing location does, is the lifespan of different elements in things, so you're getting the whole life cycle. The building life expectancy, that's how many times things are replaced and how they're maintained. The other stuff in there isn't all that important from an LCA perspective. There is an operating energy component. That's an optional thing. It's not in the tool. It's not necessary for LEEDv4. But if you use that, you would get the operating impacts as well. You'd have to input those results from something else, from like energy modeling. So the thing on the right is a sample of one of the dialog boxes for inputting a system. The Athena tool is a systems-based tool. So you do things like floor width, span. You have to understand what fly ash is and what live load is, but you don't need to be a structural engineer. So we're trying to say, you have to define what those systems are in a building at the concept level, but you don't have to be an expert. That's essentially all you have to do, is to roll up a whole bunch of inputs, and then you come up with the output. Incorporating brand-specific data. This is going to come up, inevitably. There's a whole bunch of great products down there in the trade show that have low environmental impacts. And how do we incorporate that? Athena is a generic tool. When you put gypsum board, it's just taking gypsum board as an average of the industry. If you go downstairs and say, here's this great new gypsum board product that has way lower impacts, you have to do that with caution. There's a whole bunch of things you have to, there are people that publish LCA impacts of their specific product, but they have to be not expired. They have to be applicable to the project location. They have to have the report and all indicators from a cradle to grave perspective. They need to characterize those in the same Tracy impacts that LEED references. They have to be applied to the study period of the assessment. So my suggestion on this is don't not use them, but when you use them, get help. Get an LCA specialist, get a practitioner to help you to account for that.
Or go to the manufacturer and say, you people ought to get your stuff into the Athena tool. Go see them.
Or
That's
something
really
else
what we
like
want
that.
them to do.
So the last part is about an example, just to demonstrate how easy it can be. This is a fictional thing. It's an office warehouse complex that we see all over the place, with a 2-story office and a big warehouse in the back. In this fictional one, we've got it in Minneapolis. Although it is fictional, it's based on real projects. So it's 100,000 square feet, 40-foot high, 40,000 square foot office component. Office walls are curtain wall with 30% window to wall ratio. Warehouse walls are insulated concrete block and steel stud, and EPDM roof membrane with 4 inches of extruded polystyrene. Steel columns and beams, open web steel joists, the typical thing you'd expect in a cold climate. So, let's just go here.
I think we wanted to just say a word about process on this slide, Mark, and that to do LCA and really get value back to your practice, not just going for the point hunting. You want to make the commitment to LCA early in the design process. You want to land on your LCA tool early on. You want to figure out, is this project too complicated and I'm not going to be able to do this myself? Should I get a specialist? And I'm expecting lots of those folks to begin to emerge as this credit gets more interest with so many points in there. And then, Mark, I think you wanted to say something about...
Yeah. And so I'm going to jump back just for a second. On this slide, when I actually input this building into the Athena impact estimator, and it took me probably about 20 minutes. It's not a big effort. Things aren't defined all that much, so I don't have to do this huge, breakdown. So using that kind of process, we input the baseline minute, 15 baseline building, brainstorm, test, and update. So I'm going to open up to the crowd. What would you do? How can we improve that building? Anybody? More insulation. No, that's increasing the impacts. But it's good. That's going to improve the operational impact, right? But now we got to climb. So now we've dug ourselves a hole that we got to go out of. So we've got more insulation. We made our product, our material impacts worse. What else can we do? More fly ash, good one. Okay, so let's put more fly ash in. Less cement, more fly ash, same sort of thing, but you're right. Another SCM instead of that.
Evaluate different cladding options.
Awesome idea. So use ICFs. You know, another good example. You know, the thing about that we'll stop at that's a good idea. I don't know. You know, I don't know what the impact of using ICF instead of concrete block on some of these things are. Yes.
Exactly. So
everything that's been in here that has been said has been in the tool.
So what Mark's saying is, for the step that we don't know yet, that's why we're going to use the tool. So we find out and we weigh and we look for hot spots and figure out where am I going to find my best bet change.
And you know, I've been using the Athena tool for 15 years, and I actually don't know whether ICF is better or worse. You know, I'm pretty sure that using fly ash or less cement is going to be a good thing, but I don't know the other ones, and that's what we want to encourage, to test this.
Actually, Mark, sorry, this is we can make a great little point here, because I like this. There's really no such thing, in our opinion, as a good or a bad material. Materials have impact, and so it's nice that manufacturers measure their footprint to see how they can improve their footprint. So there's footprints and then there's better footprints, and that's what they're doing. When we roll it all up in a whole building LCA, we can now balance out the materials that have a footprint with lighter ones. And we all know concrete has a significant carbon footprint, but we really need concrete in buildings. So how are we going to balance that out with something else, right?
Yeah, exactly. And so we test those. Each of those tests takes minutes, sometimes less than a minute, to do a test of a system and see what happens. Yes. Yeah. Iterates, exactly. Just keep cycling through. Awesome part of an IDP process. It can engage people and get people to think about things. So we did a whole bunch of stuff just to sort of try and play around and see if we can get to these 10% reductions. When I'm using the tool, when you start thinking about LCA, you start thinking about a thing about that, you know, building on what Jennifer said, is there's no such thing as good materials. All materials have impacts. The one with the least impact is the best material, the one that does the least amount of damage. So as soon as we do something to a material, pretty well, we're having, you know, impact. So if you think about that thing, eliminating a material is the best thing we can do. So, you know, in this case, we kind of changed the warehouse height by using, you know, shallower ductwork, you know, that kind of thing. It's a fictional building, so that was pretty easy. Made a mistake here, I just noticed last night. Fossil fuel, that gets fixed later. It's a marginal change across all of the things, not enough. So then, you know, one of the things we thought about was, what if we took the second floor and shifted it in? Which we did. We didn't do it, but we talked about it on a different project. You know, what does that do? It saves some of the envelope. It increases the structure. In that case, I don't know whether the assessor would accept this. You know, gross floor area stays the same. I think they'll accept it. But the usable floor area in the warehouse has changed because the height's changed. So part of that warehouse, and when I'm thinking about it, having been in warehouses, I think there's always those areas that people have workshops and don't need that high space. So that was what I was thinking, that we could probably make an argument. If that was a real project, I'd be asking a CIR. Now, in this particular example, you can see, again, a little bit of problem with fossil fuel. So don't worry about that one. It's marginal, you know, the impact. It really doesn't make much of a difference. A little bit higher in some, a little bit lower in others. We added structure doing that. So, you know, in that case, I would think the building owner will actually save in operating costs. They're not, you know, they're saving in capital costs, saving in operating costs, and marginal change in embodied effects. So let's just assume they kept it. We tested a few other changes. You know, changing the office component to wood-based building, partly wood-based. Putting 25% fly ash in the foundation walls and 35% in the stuff in the footings. Switching glass fiber to switching to glass fiber roof insulation, and then wood-based warehouse walls. Not saying these are achievable. I'm not saying they're code compliant. We're just playing around with the tool. There's a reason that one's red. You can see the iterative effect. All of the impacts, you know, kind of step down, and we're trying to get below that 90% level. I was kind of trying to see if I could get them all below the 90% level. And when we got to the roof insulation one, option 5 for fiberglass, you can see in ozone depletion that there was a huge jump in ozone depletion. So with my goal of getting to 90%, I couldn't do that, so I abandoned that change. and went back. So option 6 actually doesn't include option 5. Option 6 is the cumulative effect from 1, 2, 3, 4, and 6 to get down. But that's how easy the process is. And we were able to get beyond the innovation point for that.
Yeah, good. All right, so we want to wrap up in the next minute or two because we want to leave a lot of time for questions. There's no way that we can really get you up to speed in a 1-hour presentation. So over at Athena, we wrote up a guide, and we did this in collaboration with USGBC, with the LEED folks, and with the Green Globes folks, because we saw gaps in both their reference guides. Also, there's an LCA credit in IGCC and in CalGreen, their alternative performance paths. And we thought we probably need to fill in some gaps. So we wrote this guide. It's downloadable from our website, and we think it helps demystify the credit. It covers much of what we said today and a whole lot more tips to help get you through the credit. So, Mark, let's go. I think we're on our summary slide next.
Yep, although I want to, okay, we can go to this.
Don't take their question time, Mark. We're in the negatives. Come on.
Yeah.
Go ahead, sum up.
Okay, so, okay. Was that me?
Yeah.
So summary, you know, we think LCA. I think LCA. I'm an engineer. I love numbers. I don't like the airy-fairy stuff about, you know, this is good, this is bad. LCA is the best measure. It's a measure. It's a real measure of environmental impacts of a series of them. Materials are important, and it can be easy. So by show of hands, how many people do you think will use LCA in a project in the future?
Let's do this. How many have already done it? Not too bad.
That's awesome. So we made a difference, hopefully. And do we have anything else?
No, I don't think so, Mark. Let's just put up that Q&A slide, and let's invite people to come up to the microphone and want to.
So it's being filmed. So if you have questions, there's a microphone there and there.
We got one. We got a keynote.
I was just wondering if this lends itself to people gaming with the credit, because in your example, if you were like, suppose we started off with fiberglass insulation and then we assessed the styrofoam insulation on the roof and we found the impact went up. Then it's like, oh, well, I'm going to switch those around. Now I'm going to go back to the baseline building, put the foam insulation in there so that I can get credit for the fiberglass insulation in my design case. And I didn't know that was the case beforehand. How do you handle that in the LCA process?
I'd love to take that question, then you can go. Okay.
You want me to, or you don't?
No,
you go ahead.
I want to take a shot. But first of all, I want to emphasize we are not in a position to speak for LEED or the assessment process, right?
That's
okay.
fine.
Personally, in my opinion, that should completely count because you just got an important lesson about relative impact of those two things. I would let it go, but I'd be super lenient. What would you do, Mark?
I can't believe how wrong you are. I think we're LEED assessors too, and I think there's risk when you do that. I think you're definitely right. People are going to do that. People are going to play games, and they're going to do that. As an assessor, if I look, I'm going to say, wait a second, you used extruded polystyrene in a roof, and they don't really use that, and I'm going to challenge it, I think. So I think when you do, the farther you stray from that, the more risk you have. But you're absolutely right. If there's two different fundamental types, a tilt-up concrete and a steel thing, you're going to get people saying, this one's worse than this one, so I'm going to choose that as the baseline. I think that's just part of the credit.
To answer your question, yeah, there will be opportunities for.
I like viewing it as a learning opportunity. Thank you.
Yeah.
Okay, I think we should go. Let's go to this side. There's one over here, and then we'll.
Sure.
Okay.
Hi, Tian Peng with the National Ready Mix Concrete Association. And thanks for clarification. I've seen you guys present many times throughout the years on this life cycle assessment. And this is the first time it clarifies that this life cycle assessment credit, it doesn't account for the whole, all phases of life cycle, but in fact is considering the material embodied impact, which I think clarifies what the intent of this credit is. My question is on the 10% reduction. If you look at the estimator, you see that the buttons that give you the options for fly ash, for instance, just one material, it says 25%, 35%. And then you look at the buttons that say the 3,000, 4,000, then 9,000 PSI concrete. Well, that's a big range from 4,000 to 9,000 PSI. And when you try to change your impacts, environmental impacts, by 10%, I think the difference in uncertainty of what your real PSI, which would be 6,000, let's say, to the 4,000 that, or the 3,000 that you pressed, the uncertainty is already getting you the 10%. So how do you justify all this uncertainty for every single material you choose to achieve that 10%? Isn't it just easy to game that 10% is what I'm saying?
I love these questions. They're good questions. Can I go and then you go? Or do you want to go
You
first
go
this
ahead.
time? Okay. All right, first of all, come and talk to our technical guys, and they'll tell you in great detail about all the cool stuff we've done with concrete, okay, first of all. But not to get into the material, because that's not really your question. Your question is a 10% reduction, is that not within the margin of error in LCA? And I would say yes, it is. So, but I think that's okay. Because I think in this early generation version of the credit, this is really about introduction to LCA. It's about just bringing LCA into design practice. And yeah, I don't, have a huge amount of confidence in the ability of it to actually. I have confidence in LCA. Do I think a 10% change is enough? We can talk about that later. Your turn, Mark.
And yeah, the thing I'll add is that the tool is intended. You're right. It's not. I don't think any LCA tool, especially not a generic set of products, is exact. The goal is to get plus or minus 10%, with the baseline being in the middle. So when you're making that comparison between different products, it should be a fair comparison. When you're using Athena, Athena is intended to be used for everybody. So it's kind of designed for the architects and things like that who might not understand whether you need 3,000 or 6,000 PSI. There's generic things that are in there that will help you out, give you a starting point. So when you flick on that thing, it'll say, here's the strength I think you should use, and you have the ability to change it. If you want to go in between what they ask for in concrete or steel or wood or any of the other things, there are ways to do it. There are workarounds. Extra basic materials is an awesome way to work around it. And the outputs can be very detailed, way over my head. And there are workarounds if you want to get very specific.
That's a really good answer. You've been super patient, so you go next.
Can you talk a little bit about how many materials are actually in the database? And you chose a very simple building, a warehouse, but what happens when you get into high-rise buildings with fancy cladding and curtain walls, and is the tool going to work for a complicated building?
So I get to go first.
You can go first this time.
Yes, it will. The tool is trying to get the vast majority of the more common building materials and systems out there. And a lot of the relatively uncommon ones. Some of the emerging ones it won't have. So if you get into, I don't know, I've seen clay tile or stone on curtain wall, it won't have things like that. It's also designed for a sort of 10-story building. If you're doing an 80-story building, you might have to do some calculations to confirm that the structure is appropriately referenced. Does that answer your question?
If I could add, and just maybe this is a little bit of a call to action for folks that are going to maybe start using LCA. You're going to hit a few of the holes that are there. We need more voices, more pressure on industry to do their LCA work so that we can add that data. So it will come. The database is built over time. On this side.
Hello, I'm fairly new to LCA, and I'm just curious why water consumption is not included in the metrics.
It's not one of the Tracy impacts. It's we didn't come up with the credit. So water consumption, I find that kind of interesting because consumption isn't really an impact. It's more about what goes out, right? How much...
Well, during the manufacturing process,
yeah.
I mean, a lot of materials, there's a lot of water that goes into producing concrete.
Yeah, but I'll use an example. Farming rice. What would the water consumption be for farming rice,
Don't
right?
Get into the weeds.
No,
That's a complicated part of LCA.
No, this is good.
No, it's not.
Because
it's very bad.
The water consumption for rice would be huge.
Dude, we have 4.5 minutes.
I know. But the impacts of that are not, right? So consumption itself isn't a problem. It's the effluent that goes out that's the problem.
But okay, but just
okay, that could
but,
be
okay, but
right.
stop before you go there. I'm going to stop you. We do grant the Athena Impact Estimator measures water consumption, correct? Yes. Okay. Yeah. Okay, so you can get out of our tool. It doesn't happen to have been included in the LEED LCA credit.
Okay, that's
okay. Stop. Shut up.
Okay, thank you. That's kind of what I was. Yes, we can spar later.
Okay, I see you there, but I actually think he was first. So can I come back to you in a sec? Okay.
I was just curious about the regional side of when you put in your behind the tool. Is there a transportation difference between metroplexes versus rural areas, that type of thing?
Regionality is part of the tool. Rural and urban is not. So it's defined by kind of regions. If you're in the Northeast United States, that has a different transportation grid than in Utah or something like that. But if you went from, Minneapolis to a small town outside, that doesn't get accounted for.
But maybe the bigger question is that the tool is accommodating for your region and the transportation impacts related to the region. So we have a general idea of how far stuff is coming from to get somewhere close to your region.
Does the tool develop the material quantity list as you go along, or do you need that in hand before you do the inputs?
No, it develops it from the inputs that you put in. So that's a good question. One of the outputs as well is a bill of materials. So you can actually look and check if you happen to have that. You can say, you can check against that. Okay. So you don't need that.
Sorry, but there's more. It does that, and that's a useful way to use the tool if you're early in design and you don't have your own bill of materials yet.
Right.
If you're a little later and you have it and you would prefer to use your own because you think they're more exact, the tool can import that for you.
Okay.
And you can run from that.
So this is how then you talked about the speed which you could evaluate different possibilities. You basically just need your concept, and if you change your concept a little bit, you put those inputs into the tool, and then it'll give you a different output, huh?
Yeah, exactly.
Okay.
I'd encourage you. I've got all my crackerjack technical people here on the show floor, and they're doing demos all during the expo, and they'll come and answer all those detailed questions.
Okay.
Okay. No, I think
So we got two more, I think, and that'll be it.
And then we'll be done. Okay.
Can you touch upon the documentation that's required? I'm assuming this is a construction application, not a design, and that you have to prove that you used these certain assemblies and systems, and what the contractor needs to prove, or how that's documented.
You're talking about the LEED document?
Yeah, the LEED
documentation?
Correct.
LEED's not very specific. I don't think it is a construction thing. I think it's a design element. So LEED, you're required to have that table showing the 10% and not 5% reduction and things like that. And you have to describe the baseline building and the design building with a narrative, but that's all you need.
Actually, I'm sorry to interrupt you, but I want to save the last half minute for this fellow. We've actually gone through in detail through the guide and had lots of conversations with the folks at LEED and Greenbuild. And in the guide that we flashed up earlier, we tell you exactly what we think that they want you to submit.
So if the contractor changes to wood studs during construction from steel?
I think you'd have to do that. But if they, added a little bit more concrete in some place that didn't, you don't need to quantify
How about you
that.
come see us after, because I want to let you go.
Easy.
And I'll add, for people who don't know, all the V4 forms are online on USGBC.org, so you could actually see what's required in the current V4 documentation. My question, again, it goes back to the regional piece. How do you deal with the differences in the electric grid in different regions? Does that assessed as well when you look at the
Absolutely, it's all there.
Okay.
Yeah,
Okay.
critical. Yeah. All right, 1 second, we're done. Thank you very much. Thank you very much for coming.
Thank you.